Seaweed blooms now cover an area the size of South America. Massive seaweed blooms are reshaping ocean ecosystems, driven by agricultural runoff and warming waters. The scale of these blooms is unprecedented. Current formations now cover a surface area equivalent to the entire continent of South America. This is not merely an ecological oddity. It's a direct consequence of human activity and climate change, with far-reaching consequences for marine life, coastal economies, and global weather patterns. The science behind the blooms, the primary driver behind this explosive growth, is excess nutrients, mainly nitrogen, and phosphorus leaching into the ocean from agricultural fertilizers. This runoff fuels rapid algal reproduction, creating what's known as a bloom. These aren't the microscopic algae of familiar red tides. The dominant species in these massive formations is sargassum, a type of brown seaweed that can grow to enormous sizes, forming floating mats visible from space. These blooms are not new, but their scale is. Over the past decade, they've grown exponentially, spreading across the Atlantic and Caribbean seas. Researchers using satellite imagery and machine learning algorithms have tracked their expansion, confirming the alarming growth trend. The problem is compounded by global warming, which increases water temperatures and creates ideal conditions for algal proliferation. Why this matters: the impact of these blooms is multifaceted. Marine ecosystems. Dense seaweed mats block sunlight from reaching coral reefs and seagrass beds, suffocating these vital habitats. Corals and other marine life struggle to survive in these oxygen-depleted zones. Eels and other species that depend on these habitats are also impacted. Coastal economies. Tourism and fishing industries suffer as beaches become unusable due to decaying seaweed. Rotting algae release hydrogen sulfide, a toxic gas that causes respiratory problems and foul odors. Shipping and navigation. Massive mats hinder ship traffic, disrupt aquaculture operations, and can even damage boat engines. Weather patterns. Some scientists believe these blooms alter regional weather patterns by affecting evaporation rates and cloud formation. The role of aquaculture and nutrient pollution. Aquaculture. The farming of fish and other aquatic species contributes to the problem by releasing waste products into the water. While aquaculture is essential for food production, its current practices often lack sufficient waste management. This, combined with agricultural fertilizer use, creates a perfect storm of nutrient pollution. The problem isn't confined to land-based runoff. Bacteria break down organic matter in the ocean, releasing nutrients that further feed algal growth. The cycle is self-perpetuating unless drastic interventions are taken. The future of seaweed blooms. The trend is unlikely to reverse without significant changes to agricultural practices, wastewater treatment, and climate policies. Reducing fertilizer use, improving drainage systems, and investing in sustainable aquaculture methods are crucial steps. However, the inertia of existing systems and the ongoing effects of global warming suggest that massive seaweed blooms will continue to expand in the coming years. The scale of these blooms is a stark reminder that human activity is fundamentally reshaping marine ecosystems, says an unnamed oceanographer who has been studying the phenomenon for over a decade. We are creating conditions for nature to respond in ways we may not fully understand, but are increasingly unable to control. The seaweed blooms represent a clear signal that the Earth's oceans are under severe stress. Addressing this problem requires a systemic shift towards more sustainable practices and a greater recognition of the interconnectedness between human actions and planetary health.